This module covers the way the branches of the autonomic nervous system balance each other to maintain homeostasis. As discussed in the previous module, the autonomic nervous system, or ANS, is responsible for the involuntary innervation of glands, smooth muscle, and cardiac muscle, such as that found in most internal and visceral organs. The two branches of the ANS, the parasympathetic and sympathetic nervous systems, maintain a steady equilibrium, allowing us to adapt to many different situations. This is generally done using dual innervation, whereby target tissues receive inputs from both sympathetic and parasympathetic systems. Generally, sympathetic and parasympathetic neurons arise from different parts of the spinal cord. Parasympathetic neurons arise from cranial and sacral spinal regions, while sympathetic neurons arise from thoracic and lumbar spinal regions. Activation of the parasympathetic nervous system allows the body to rest and digest, while activation of the sympathetic nervous system prepares the body for a fight or flight response. For example, stimulation of the sympathetic system can lead to increased heart rate, which is in line with a fight or flight response to stress. When the stress passes, activation of the parasympathetic system assists in lowering the heart rate. This demonstrates antagonistic control, where one ANS branch is excitatory and the other is inhibitory. For the majority of organs, the two ANS branches exert opposite effects that help maintain homeostasis, a process known as physiological antagonism. Sympathetic innervation of the eyes results in pupil dilation and adjusting accommodation for far vision, while parasympathetic innervation results in pupil constriction and accommodating the eyes for near vision. Sympathetic innervation causes bronchodilation, whereas parasympathetic innervation causes bronchoconstriction. Heart rate and cardiac output are increased by sympathetic input and decreased by parasympathetic input. The maintenance of this balance involves a baroreceptor reflex. The stomach, intestine, rectum, and bladder also receive dual innervation. Gastric acid and gland secretions in the stomach, as well as gut motility, are increased with parasympathetic input. In contrast, activation of the sympathetic system reduces gut motility. Sympathetic activation causes contraction of the sphincters of the bladder and rectum, reducing the need to go to the bathroom, while parasympathetic activation causes relaxation of the sphincters and contraction of the smooth muscles of the bladder and rectum, leading to urination and passing stool. As for the male sex organs, the sympathetic system governs ejaculation, while the parasympathetic system controls erections. This dual but opposite innervation, allowing antagonistic control, is a hallmark of the ANS. While it is responsible for the homeostasis of most internal organs, it does not apply to sweat glands, the adrenal medulla, and most blood vessels. Instead, these organs are innervated solely by the sympathetic system and rely on tonic or up-down regulation. In most cases, parasympathetic responses are mediated by muscarinic receptors, whereas sympathetic responses are mediated by alpha and beta adrenergic receptors. While sweat glands are sympathetically controlled, they are activated by muscarinic receptors. Consider the following scenario. Cheetahs often need to work for their supper by running fast to catch up to their prey. In this scenario, the sympathetic systems of both the cheetah and its prey are fully activated. Blood flow is directed from visceral organs to where it is needed most, the skeletal muscles. In other words, the blood vessels in the viscera, skin, and brain constrict, while the blood vessels in the skeletal muscles dilate. So what causes these different effects at distinct blood vessels? The answer is that different blood vessels express different subtypes of adrenergic receptors. Blood vessels in the viscera, skin, and brain predominantly express alpha adrenergic receptors, which constrict upon sympathetic stimulation. In contrast, blood vessels in skeletal muscles predominantly express beta adrenergic receptors, which dilate upon sympathetic stimulation. This difference in receptor expression allows for spatial control of blood flow. Blood vessels are mainly controlled by the sympathetic system. The parasympathetic system is minimally involved through nitric oxide release as a result of muscarinic receptor activation. In summary, The sympathetic and parasympathetic nervous systems exert opposite effects to maintain homeostasis. The sympathetic nervous system mediates fight or flight responses, while the parasympathetic nervous system allows for rest and digest. Most organs receive dual innervation from the ANS, with the exception of sweat glands, blood vessels, and the adrenal medulla, which receive tonic or up-down regulation from the sympathetic nervous system only.